Hi everyone, my name is Urvin and today I'm making this video to present my overall system working and on which I have also made a PPT which I'll be explaining and the rest of the working as well. So today I'm presenting my project titled Noise Pollution Temperature Monitoring and System Analysis, which monitors the academic environment. So Introduction. Growing concern over noise and thermal discomfort in learning environments. These days, I've been observing that there is a growing concern over noise and thermal discomfort, which really affects the students' performance and like efficiency in speak recognition and so on. So the importance of real-time data to monitor and mitigate such issues really need to be implemented. And the goal is to build a smart IoT based system with an automated actuation, which will be showing you the temperature control as well as with some alerts also. So talking about the literature review, existing systems lack real-time visualizations and local actuation. MQTT commonly used for IoT communication need and there is a really need for a lighter communication protocol such as MQTT, cloud storage, as well as a dashboard to analyze the whole data. So the system objectives are to collect these environmental data and automatically trigger fan-based cooling when the temperature exceeds the threshold, and to also provide manual override of the fan's speed via push buttons. This system also publishes data to the MongoDB Atlas, which is a non-SQL database. And for the data visualization, I have been using the Plotly Dash, which shows the three variables, noise, temperature, and humidity for the efficient data analysis. So this is the hardware components I've used in my project, and this is the overall system design for my project. The core component of my system is the Arduino Nano 33 IoT, and which gathers data from the LM393 sound sensor and a DHT22 temperature humidity sensor. So when the temperature exceeds a threshold, a DC motor fan is automatically activated through the L289N to L298N motor driver, simulating an auto climate control mechanism. And also push buttons are provided to for the manual override, which shows the user interaction as well. So let's move to this is the hardware implementation. Integrated sensors to the Nano 33 IoT, and this is the overall system I have implemented. And, talking about the system architecture, I've been using Arduino IDE for the sketch making and sensor data collection, and an MQTT broker, which is HiveMQ for publishing, subscribing, messaging, for like for subscribing topics for the environmental data such as noise, temperature, and humidity. And talking more, the data is stored in the cloud using MongoDB Atlas and visualized through a lively Plotly Dash dashboard. This architecture ensures seamless data flow, analysis, and user interaction. This is the MQTT communication, which is really lightweight and is TLS based, which which ensure that our connection is securely transmitted and the data is transmitted without any security concerns and is encrypted. So this is the cloud storage I've already discussed. These are the MongoDB is a non-SQL database. Python scripts are used to push the data to the MongoDB via pymongo. I will also explain all the related libraries as well. And this is the plotly dash used for live sensor data. I have used the Python environments for this criteria. Okay, so this is the conclusion. um, Future enhancements I can make is the smartphone alerts and integration with the campus HVAC systems and noise pattern classification. This would greatly enhance the academic comfort via automation. Thank you for listening to my presentation. Now I'll be showing you my codes and then at last I'll be presenting you my working. Okay. Okay, so talking about the Arduino Sketch, I've used this to connect to read the data from the sensors and then publish it over the MQTT. And these are the necessary libraries which I have used here. These are Wi-Fi Nina. So this library used as it enables Wi-Fi connectivity for Arduino Nano 33 IoT. I also want to include that the Arduino uh, is has an inbuilt Wi-Fi Nina. Um, Also, I'll be including the Wi-Fi SSL client library. Um, this provides secure TLS communication over a secure MQTT connection. So TLS is basically transport layer security, and that ensures secure communication over a network by encrypting data and verifying identities like noise, temperature, and humidity. So this is the library for the DHT. It interfaces the temperature and humidity sensor. And this is the wire.h. It enables I2C communication between the Arduino and I2C compatible devices like the LCD, as I have used an I2C LCD 16 into 2 resolution. And this library is for the controlling the LCD display via I2C protocol with minimal as the I2C supports minimal pins for connecting LCD with the Arduino. And this is the whole code you can see. And now I'll be showing you my Plotly. This Python script is for the live data dashboard. And first of all, I have used the time. This provides functions for working with the time, such as delays, timestamps, as and so on. And this is the threading library. It enables concurrent execution of code using threads. Okay, so the next is the deck collections from collection import deck. It provides a double-ended queue for like fast appends and pops from both the ends. Deck is like I have used for buffers, like for buffering data, and this is and appending data using buffers. Like yeah. So next is the dash. This is a Python library used for interactive web applications, mainly for the data visualization. And and at last, I'll be talking about the pymongo over here. Yeah, pymongo. This library, as I have also discussed in my PPT, this library is used to interact with the MongoDB Atlas. And this is the MQTT client. paho.mqtt.client. This is a Python client for connecting to MQTT brokers and like handling publish and subscribe messages. Okay, so this was my whole code for the MongoDB connecting with the MongoDB Atlas, and this is for the live data dashboard using Plotly. And now I'll be moving to the working, and I'll show you how my system works. Okay, so this is my system currently working, and it is currently connected with the MQTT protocol using HiveMQ over here, and you can see an I2C LCD display which also alerts the user when the noise thresholds are exceeds. And this is here you can see the messages like and which are subscribed to the topic decibels, humidity, temperature, and it is currently using the MQTT protocol over here. And now I'll show you how it is how it transmits the data to the MongoDB and generates a live Plotly dash. Okay, so I have already discussed that I have used these two codes. This one is for the data visualization, and I'll run it. Okay, so I have now ran this code by using this command python 9.2 live, as the Python script name is 9.2 live, and .py is the extension of the file. And similarly I have used the 9.2 Mongo to connect to the MongoDB Atlas, and now I'll show you the dashboard. Here you can see the dashboard. These are the temperature, humidity, and decibels. As I am speaking, so the noise is currently varying, and you can also see over here. Okay, so now I'll be showing you the MongoDB Atlas where the data is stored. Here you can see this is my MongoDB Atlas, and over here inside the sensor data a node of env data is being created, in which the data is being saved. Over here you can see the along with the timestamp, and these are the readings: humidity, decibels, and here you can see over here next, these are whole readings I have been storing in my cloud database for better visualizations. So this was my whole project over here, and this fan will work only when the temperature exceeds a threshold of 28 degrees Celsius. So currently it is 26, and over here you alert is also seen when the decibel is being crossed over 80, and I'll show you here. Okay, so I have tried my best. You can see a little maintained decorum has been observed. This was due to the crossing of the threshold. So this is my whole design system, and based on it I have drafted my conference, in which I have included readings for about a week, and observed my class academic environment where I study. So thank you for watching. This was the whole from my side.